Hello students, in the last video we have studied about the Coastal-Lewis approach of electronic theory of chemical bonding. Okay, and in the last class I explained you of the Lewis approach to the electronic theory of chemical bonding. Today we are going to study about the Coastal approach of electronic theory of chemical bonding. Okay, how did Coastal explain this? Okay, chemical bonding. Okay, what did he do? He said that the electronegative and electropositive elements are separated by the noble elements or the noble gases. Okay, actually electropositive elements, what they do? They give the electrons. Electronegative, what do? They take the electrons. Okay, so naturally for here I have taken the example. With the example Coastal has explained it also, like if we are taking sodium, okay, sodium will give one electron, isn't it? So there is a loss of electron. If there is a loss of electron, it is electropositive in nature. Fluorine, it is taking an electron, it is gaining an electron. As the result we see what? A minus sign over here. Okay, so it is what? Electronegative in nature. And these two elements will be separated by a noble gas. Okay, and that noble gas is what? Neon, isn't it? Now, sodium and fluorine, what do? They attain stable configuration as noble gas by what? Losing an electron or gaining an electron, isn't it? Like sodium is losing an electron and fluorine is gaining an electron. Okay, so here there is an exception of helium. Okay, why we are saying helium? Okay, why? Because here in the noble gases, all the gases are having what? 8 electrons in its outermost shell, but helium is having how many electrons? 2 electrons. So for hydrogen and helium, instead of following the octet rule, duplet rule is followed, because here what happens in the outermost shell, 2 electrons are there, and these 2 electrons only makes them what? Stable in nature. Okay, hydrogen has got only 1 electron, so it will what? It will take an electron. Okay, or it will give an electron to become stable, and helium has got 2, so it is already stable and it is kept in the p block elements along with the noble gases. Okay, now here you will see these all the noble gases, they have stable configuration of 8 electrons in its outermost shell, having the electronic configuration of ns2 and np6. Okay, now these sodium and fluorine ions, okay, they stabilize by what? Electrostatic force of attraction. Why? Because here you will see what? So sodium, it gives the electrons, fluorine, it takes the electrons. So there is some strong force which is helping them to form the bond, and that bond is due to the electrostatic attraction force. Okay, like chlorine, if we are seeing, okay, chlorine, it takes 1 electron and it becomes what? 1 negative charge of chlorine comes here. So if we want to write the electronic configuration according to this Coastal approach, okay, we can write neon has got how many? 10 electrons, isn't it? And sodium has got how many? 11 electrons. Neon completes in the second cell only with having 2p6, but here sodium is having 11 electrons. As a result it becomes what? 3s1. So neon plus 3s1, okay, it forms what? The configuration of sodium. Okay, and if this sodium is giving 1 electron, then what happened? It gets the configuration of neon. Okay, now chlorine, okay, taking 1 electron, it becomes what? A negative charge comes in chlorine. Okay, so when we want to define, or when we want to express the electronic configuration of chlorine, we can write it as neon 3s2 3p5. Neon has what got? It has got 10 electrons, and chlorine has got how many? 17. So here representing those 10 electrons by neon, and then 3s2 and 3p5. Okay, and naturally what happens when one electron gets added to it, it gets the stable configuration, okay, and that is of argon. Okay, now sodium plus chlorine, it forms what? Here it is giving one electron, it is taking one electron, forming what? NaCl, or you can write it as Na plus and Cl minus, because Na has given one electron to chlorine. Okay, like that other examples also we can take, like Ca2 plus 2F minus. Okay, it forms what? CaF2. Okay, and here CaF2 can be written as what? Ca2 plus F minus whole twice, because one electron has gone to one fluorine and another to another fluorine. Okay, so this here actually what is happening here, the electrons are moving on, isn't it? And as the result here, bonds which are formed are known as electrovalent bond. Here the transfer of electron is taking place from what? The sodium to chlorine. A strong electrostatic force of attraction acts over there, and thus forming a electrovalent bond. Okay, other bonds are also there, and regarding electrovalent bond also we will be studying step by step. Now let us study about the significance of Coursel's approach to the theory of what? Chemical bonding. He said about what? The chemical bond, okay, which was his great achievement, because here this electrovalent bond could say about the electrovalency also. Okay, how? Suppose if we are taking calcium fluoride, okay, so the charge which calcium acquires is +2 and fluorine is -1. Two fluorine atoms are there, isn't it? This is giving two electrons, one to one fluorine atom, another to another fluorine atom. Okay, so now the electrovalency of calcium becomes what? 2, and fluorine becomes only 1, because here two atoms are fluorine of there, which is accepting the electrons. For one atom it becomes what? -1. Okay, so electrovalency could also be taken out with the help of Coursel's approach, isn't it? Now next is, he gave the explanation of ionic compounds. He explained how these ionic compounds are formed. Okay, and he also said about that it recognized the large number of compounds. Actually, he said about what? The ionic compounds, and he could find that number of compounds could not form this ionic bond. Okay, somewhere left over. It means some other bonds are also there. This also Courcel could find out. Okay, so he could recognize that a large number of compounds did not fit, okay, in his explanation. Okay, so later on Courcel and Lewis gave electronic theory of chemical bonding. Okay, they said what? That atom can be stable or can have 8 electrons in its outermost shell by the transfer of electrons, it means gain or loss of electrons, or by sharing of electrons. Okay, if these two bondings are there, okay, if these two transfer of electrons and sharing of electrons are there, with this only they can complete their octet, and this octet, where it is completing, in the outermost shell or the valence shell, and this is only known as what? Octet rule. So all the atoms of the elements, okay, go into this octet rule in order to become what? Stable. Now let us study about the covalent bond. Okay, electrovalent bond was explained by Courcel. Now covalent bond, actually sharing of electrons, the idea was given by Courcel and Lewis, but the covalent bond was totally explained, or this term was introduced by Langmuir with the help of Lewis theory. Okay, so he explained what? The covalent bond formation. So this is known as what? Lewis-Langmuir theory. Okay, for example, if we are taking a chlorine molecule itself, you are seeing how many? Only one electron of this and this is being participating. So here what will happen? Here only one pair of electrons is taking part in sharing, and so it is known as what? A single bond. Okay, only a single bond will be formed over here. Okay, now when we come to the double bond, okay, take the example of carbon dioxide. Carbon has got 4 electrons in its valence shell, okay, oxygen has got 6, okay. Oxygen also needs 2 electrons, carbon needs 4 electrons, but here you are seeing what, 2 atoms of oxygen are there. From here it is taking 2 and from here it is taking 2, and as the result what is formed? Double bond is formed. So this type of covalent bond is a double bond, okay. Now next is when 3 pairs of electrons are shared. We can take the example of nitrogen molecule. Nitrogen has got how many in its last shell? 5 electrons, isn't it? Actually, what is the atomic number of nitrogen? It is 7. So it becomes what? 2 and 5. So outermost shell is having how much? 5 electrons. So now here you see 2 electrons. Okay, they are free in nature, but here the 3 electrons are taking part in bond formation. Here also from nitrogen 2 is free and 3 is taking part in the bond formation. Naturally here 3 pairs of electrons are being shared, and as the result forming a triple bond. So 3 types of covalent bond: single bond, double bond and triple bond. Apart from electrovalent bond and covalent bond, one more bond is there, that is coordinate bond. Okay, actually this is a type of covalent bond only. Okay, here what is this actually? It is the mutual sharing of electrons between 2 atoms, but the shared pair of electrons is contributed only by one of the 2 atoms. Other simply participates in sharing. This I am going to explain you with the example. Okay, suppose if you take example of O3. Okay, so how this will be formed, this molecule? Okay, so 3 oxygen, isn't it? Here it is consisting of 6 electrons. Okay, here also consisting of how many? 6 electrons. Okay, and here also consisting of how many? 6 electrons. So actually what will happen? You can see I have made the dots in a different manner. Actually what happens? This oxygen shares the one pair of electrons and this one pair of electrons. It means 2 pairs of electrons, okay, forming a double bond between these 2 oxygen. Okay, what happens here? You can see 4 plus 4, 8, octet of this oxygen is complete. Okay, now let us see of this. Okay, 4 plus 4, this also complete. Okay, so this electron can't go into bonding with this because it will not follow the octet rule. So what will happen here, after this is being completed, its octet is being completed, what happens? It partially shares the electron with this oxygen atom. It donates its electron, keeping this electron itself for octet rule, following the octet rule, and also donating this with what? The another oxygen. Okay, it means here what happened? One which is sharing this electron with this also, okay, it will acquire a partial positive charge, and here as this is being shared with this oxygen also, it acquires a partial negative charge. And this type of bond in which keeping the electrons and only one of it is participating in sharing of the electron or donating of the electron or participating of the electron in the bond formation is known as what? Coordinate bond. Here only this oxygen is contributing in sharing with this oxygen atom. Okay, and this type of bonding is known as coordinate bond, and this is denoted by an arrow. Okay, where the electrons are being shared or is being taken or is shown by the arrow, and which is contributing is shown by the tail of the arrow. Okay, so this is all for today. Good day. Take care.